We're down here at Kayak Point, Washington, to introduce the pillar boat. Now, a pillar boat is not like any other kind of boat. It is actually a platform supported on at least 3 sets of spar buoys. Now, each set of spar buoys, this one has 5 buoys to the cluster. You can have as few as 3 or as many as you want. The idea is that the spar buoys are tuned to a certain frequency. So I can bounce the whole station. That frequency is much longer than the period of the waves that you expect to encounter. And that way you can watch as these waves of the appropriate size come through. And you can see the glass on the top hardly rocks at all. So I'm going to create some more waves with this ball to show how the waves of the size that this is intended to resist have no effect on it at all. So that's the basic idea behind the pillar boat. Each one of these I've produced is about a 2-inch diameter float. The actual models would be up to 100 times to even 300 times bigger. So these waves that you see coming through that are about 1 inch to 2 inches tall would be between 20 to 50 feet tall compared to the real model. So you can see how it could ride out some pretty rough seas very easily. Okay, this is a 2-inch model, so it's about 1/100th scale model. The thing is, with the scale and the lifting capacity, it goes up with the cube of the scale. So this one, you can see I'm pushing down maybe with 5 or so pounds of force before the buoys are overloaded. So 100 times 5 pounds to the 3rd power, that's a lot of weight these can hold. The big ocean-going vessels could support a city, airports, casinos. Okay, so each of the spar buoys is a long cylinder that goes deep into the water. And at the base it has a large ballast. You can see lead weights hanging from those. If you can look down into the bottom, you can see through the water. The top is gimbaled so that the spar buoy is free to rotate. The cluster is also on a ball and socket joint here, so as the waves come through, it's free to move in any direction. The waves toss the buoys without hardly moving the joint. So now each of these joints will ride up and down independently on their own cluster, and the average position of the platform will hardly change at all.